Hello दोस्तों, welcome to KP Academy and here we are with the new video on effect of operating parameters on performance of vapor compression refrigeration system. The parameters are suction pressure, discharge pressure, superheating and subcooling. So let's discuss one by one. So here is the effect of suction pressure on performance of vapor compression system. So this is the standard VCR cycle 1, 2, 3 and 4. The refrigerating effect for this cycle is what? RE H1 minus H4. The work of compression is H2 minus H1. The coefficient of performance for the system is what? H1 minus H4 divided by H2 minus H1. That is refrigerating effect divided by work of compression. Now if somehow the suction pressure drops from P1 to P1 dash, the effect of this is what? The refrigerating effect drops. Earlier refrigerating effect was H1 minus H4. Now it's H1 dash minus H4 dash, which shows refrigerating effect drops. About work of compression, it increases from W to W dash because the line 1 to 2 is shifting towards right side, which increases the work of compression, that is W dash, right? So here in this case, because of drop in suction pressure, refrigerating effect drops, work of compression increases, and result of that is what? Drop in COP, because numerator is decreasing and denominator is increasing. Because of this parameter COP is dropping. So there is a drop or decrease in the COP of the system because of drop in suction pressure. So the summary: because of drop in suction pressure, refrigerating effect decreases, work of compression increases and COP decreases. Next is that specific volume at suction increases. If you see here one point, if I say the specific volume at one point is V1 and at one dash point V1 dash, the V1 dash is more than V1, right? The V1 dash is more than V1. So specific volume at suction line increases because the specific volume lines are like this. On the pH chart, the volume lines are like this, right? And the values is increasing from downside towards the downside. So that's why the specific volume at suction line increases. And if the specific volume at suction line increases, then piston displacement is also increases, right? Because compressor has to work harder, which increases the piston displacement. Okay. Next is causes of suction pressure drop in the VCR system. What are the different reasons to have drop in suction pressure in a VCR system? So very first is what? Long or improperly sized suction line. Long or improperly sized suction lines means what? If there is a less diameter pipe or longer length pipe or any other sized improperly sized line, right? So because of that, what happens? The frictional resistance increases, right? Because of that, frictional resistance increases, and which increases the pressure drop, right? So due to long or improperly sized suction line, the frictional resistance increases, which increases the pressure drop. Along with this one, if there is a poor layout, for example, if I say there are too many bends available in the suction line, too many fittings are available in the suction line, which also the reason for frictional drop, or we can say frictional resistance, which increases the pressure drop. Okay. Next is accumulation of oil or liquid refrigerant in suction line. Oil return issue, if there is an issue in the oil return, right, in the compressor, then it leads to the oil logging, right? It leads to the oil logging. For example, or oil or liquid refrigerant, it also reduces the effective flow area. If there is an oil present in the suction line, then it reduces the effective flow area for the refrigerant, which increases the pressure drop. Okay. Next is blockages or restrictions. If there are foreign particles present or some debris is present or for example there is a ice formation in the suction line, right, due to the moisture, which increases the compressor load, okay, which increases the compressor load and reduces the refrigerating or cooling capacity, right. So because of that, again suction pressure drops. Finally, if there is a suction line leaks, if there is a leakage in the suction line, and for example because of that non-condensable gases takes entry into the suction line, which reduces the system efficiency, okay, which reduces the system efficiency. Because of that, the mass flow rate of the refrigerant reduces because of non-condensable entry of some gases, okay. So because of that, mass flow rate of refrigerant reduces, which reduces the evaporator capacity to absorb the heat, okay, right. Next parameter, discharge pressure. So effect of discharge pressure on performance of vapor compression system. Now if discharge pressure increases, the line 2 to 3 shifts from this to this side, okay. So because of that, what happens? Refrigerating effect drops. There is a drop in refrigerating effect, right, because earlier refrigerating effect was from 4 to 1, but now it is from 4 dash to 1. So refrigerating effect drops, that is RE dash. What about work of compression? Work of compression increases. So because of higher discharge pressure, what is happening? Refrigerating effect drops, work of compression also increases, and that is the reason there is a less COP, okay. So COP decreases when we have discharge pressure higher side, okay. So the summary, because of higher discharge pressure, the refrigerating effect decreases, compressor work increases, and because of that, the COP of the system reduces. Mass flow rate of refrigerant increases. Why the mass flow rate of the refrigerant increases? Because the compressor is working harder, and if the compressor is working harder, mass flow rate of refrigerant increases, okay. Now, causes of discharge pressure rise in the VCR system. What are the different reasons to have higher discharge pressure? Okay, the very first is what? High condenser temperature due to poor heat rejection to the surrounding, which leads to the less effective condensation. Okay, if there is a high surrounding temperature, then condenser temperature should be higher in order to reject the heat, right? And if there is higher condenser temperature due to poor heat rejection to the surrounding, then it leads to the what? Less effective condensation, and for that compressor has to work harder, and because of that the discharge pressure increases. Next is overcharged refrigerant in the system, and if there is a overcharged refrigerant, which leads to the higher pressure in the system, especially at discharge side. Okay, next is high ambient temperature. If the surrounding temperature is more, then in order to reject the heat to the surrounding through the condenser, then compressor has to work harder, because the heat rejection from the condenser takes place only when there is a temperature difference from surrounding to condenser temperature, and if the condenser temperature is higher, then in order to make that higher, the compressor has to work harder, and that's why the discharge pressure increases. Next, non-condensable occupy space leads to the pressure rise. If there are some foreign particles, non-condensable gases present, which occupies the space in the condenser line or discharge line, due to which pressure rise takes place, right? And very last is what? Higher refrigerant load. If there is a higher refrigerant load, then compressor has to work harder, and because of that discharge pressure increases. But because of increasing discharge pressure, the COP of the system drops. Okay. Next, third effect of superheating. Now, in standard VCR cycle, at the entry to the compressor, we have saturated vapor. The refrigerant is at saturated condition, right? Saturated vapor. But in superheating case, we increase the temperature of refrigerant before passing it to the compressor. right? So this rise in temperature is called as superheating. Okay, this rise in temperature is called as superheating. Now, because of superheating, the refrigerating effect increases. Okay, the refrigerating effect increases from RE to RE dash. What about work of compression? Work of compression also increases. The reason is that the line 1 to 2 is shifted towards right side, and that is the reason 1 dash 2 dash line, the slope of this line is what reducing, and because of that the work of compression is increasing. Okay, so in this case what is happening? The refrigerating effect increases, along with that the work of compression is also increases, right? In the COP formula, numerator is also increasing and denominator is also increasing. So that is the reason we cannot say whether COP increases or decreases unless we know what type of refrigerant is used in the system. That means the COP depends only on refrigerant used. What kind of refrigerant is used in the system? Okay. The summary: because of superheating, refrigerating effect increases, compressor work increases, and COP depends on what type of refrigerant used. Okay. Next is condenser heat rejection load increases. Condenser heat rejection load increases means what? Condenser has to work harder to reject the heat to the surrounding. So earlier the condenser has to work condenser has to reject heat from 2 to 3, but now it has to reject heat from 2 dash to 3. That's why the condenser heat rejection load increases. Next, specific volume at suction increases. If you see the one point, it has less specific volume than 1 dash. So 1 dash is now having more specific volume. Okay, and because of that piston displacement increases, right? And finally COP depends on refrigerant which is used over there. Okay, now we can understand this better way. This is the TS diagram for superheating cycle, right? Now suction temperature increases from T1 to T1 dash, which is desirable. Now why it is desirable? Because if for example there are some liquid droplets of the refrigerant in the suction line and it enters into the compressor, that there is a damage of compressor possible. There is a possibility of damage of compressor, right? So in order to avoid that, what we do, we superheat the refrigerant before it enters into the compressor, right? So that's why superheating the refrigerant before entry to the compressor is desirable. Next, discharge temperature increases from T2 to T2 dash, which increases the condenser heat rejection load. The temperature is increasing from T2 to T2 dash. Increase or decrease in COP depend on what type of refrigerant used. Now, if we use freon refrigerant, then COP increases, and if there is ammonia as a refrigerant, then COP decreases. Okay. Now, finally, effect of subcooling on performance of VCR system, right? Subcooling means what? Dropping the refrigerant in the condenser, dropping the temperature of refrigerant in the condenser from saturation temperature to 3 dash point. Okay, so that is called as subcooling, and delta T is what? The subcooling, right? Amount of subcooling, right? Now, because of subcooling, what is happening here? The refrigerating effect increases. Okay, refrigerating effect increases. H1 minus H4 dash. Earlier it was H1 minus H4. Now it is H1 minus H4 dash. So that's why refrigerating effect increases. What about work of compression? Work of compression remains same. So there is no change in work of compression, right? That means for subcooling, for the same work of compression, we can have higher refrigerating effect, and the effect of that is what? Higher coefficient of performance. Okay, effect of that is what? Higher coefficient of performance, right? Flashing of refrigerant decreases. So in earlier case, in the standard cycle, the flashing starts from this 3.2 up to 4 point. But now in this subcooled region, the flashing starts from this point, right? Flashing starts from this point to 4 dash point, right? So there is a drop in flashing. Okay, so that's all for effect of different parameters on the performance of VCR system. Okay, there is summary also, right? So effect of subcooling on performance of VCR, there is a summary also, that the refrigerating effect increases because because of subcooling, refrigerating effect increases. There is no extra work input required, and that is the reason the COP of the system increases. The flashing of refrigerant in expansion device decreases, leads to high cooling capacity. Okay, so this is what summary of subcooling on performance of VCR system. That's all. Thank you so much.